The 4107 was just a picture of the hatch, so we had not even gotten to the step in the procedure where it said to do the MLI yet, so that's why it wasn't in config there. And then as we proceeded kind of working our way out, the 4107 was just a picture of the hatch, so we had not even gotten to the step in the procedure where it said to do the MLI yet, so that's why it wasn't in config there.
And those are all great.
And then
Thank
as
you,
we
Shane, for
proceeded
the
kind of working our way out,
Taking another live look at the SpaceX Dragon cargo craft attached to the space-facing port of the Harmony module. Dragon is returning to Earth later tomorrow with about 5,300 pounds from the station. It will conduct a deorbit burn, which will last about 9 minutes. It'll then take about 30 minutes for Dragon to re-enter the Earth's atmosphere for its parachute-assisted splashdown in the Gulf of Mexico, on the coast of Tallahassee, Florida, around 10:30 p.m. Central Time, 11:30 p.m. Eastern Time. There are a couple milestones we'll see Dragon meet this morning. First, those departure burns, but then it will cross the keep-out sphere, an invisible line around the station with a 200-meter radius. It will keep heading away from the station and will stand by until it makes its way out of the approach ellipsoid, another invisible line considered the neighborhood of the space station. These invisible lines are where we have checkpoints for the vehicles on the way to and from the International Space Station. Once the command to undock is sent, we will be looking for 2 sets of 6 hooks from the International Space Station to be released from Cargo Dragon. After open, 2 small undocking burns that will last less than a few seconds, and then we'll begin to see separation of the vehicle. The spacecraft will start to slowly drift away. Next, Dragon will have a few departure burns to get into the proper position away from the station for its eventual deorbit burn scheduled for tomorrow around 9:45 p.m. Central Time. That will slow Dragon down enough to drop it out of orbit and send it towards its landing zone, splashing down in the Gulf of Mexico approximately 10:30 p.m. Central Time, 11:30 p.m. Eastern. Splashdown will not be covered live, but to keep up with the mission, go to www.nasa.gov.
Dragon undock and departure review complete. ISS crew is ready for departure.
Copy.
There are currently 7 crew members living and working aboard the International Space Station. Expedition 65 consists of NASA astronauts Shane Kimbrough, Megan MacArthur, and Mark Vande Hei, Roscosmos cosmonauts Petrov Dubrov, Oleg Novitsky, Aki Hoshido of JAXA, and Thomas Pesquet of the European Space Agency. As a part of the commercial crew program, NASA astronauts Megan MacArthur and Shane Kimbrough, launched alongside European Space Agency astronaut Thomas Pesquet and Japan Aerospace Exploration Agency astronaut Aki Hoshido on April 23rd from the Kennedy Space Flight Center in Cape Canaveral, Florida. This mission, known as NASA's SpaceX Crew 2, docked to the International Space Station on April 24th and is set for a six-month science mission. The Crew 2 mission is the second of 6 crewed missions NASA and SpaceX will fly as a part of the agency's commercial crew program. You are currently seeing live view of the International Space Station Flight Control Room. We're in a brief handover between satellites right now, but we'll be regaining communications here shortly. And we're about 8 minutes out from a final go, no go around the room here in Mission Control Houston to see whether Dragon will be ready for undocking today. If you are just joining us, we are live here in the International Space Station Flight Control Room with a live view of the SpaceX Dragon cargo craft. This morning we bring you live coverage of the autonomous undocking of Dragon from the International Space Station for its return to Earth with almost 5,300 pounds of research and return cargo. Originally planned for Tuesday, July 6th, NASA and SpaceX waived undocking of Cargo Dragon due to Tropical Storm Elsa. After a series of weather briefings assessing certain parameters like wind speeds and wave heights, NASA and SpaceX chose a new splashdown site off the coast of Tallahassee, Florida, scheduled for 10:30 p.m. Central Time tomorrow. Dragon's journey to the International Space Station began on June 3rd when the spacecraft launched on a Falcon 9 rocket from the Space Launch Complex 39A at Cape Canaveral, Florida. The spacecraft lifted off over the Florida coast with more than 7,300 pounds of science investigations and supplies to begin its two-day journey to the International Space Station. Dragon arrived 2 days later on June 5th with Expedition 65 flight engineers Shane Kimbrough and Megan MacArthur monitoring the arrival from the station's cupola. Taking another live look at the SpaceX Dragon cargo craft attached to the space-facing port of the Harmony module. Dragon is returning to Earth later tomorrow with about 5,300 pounds of research and return cargo. About 36 hours after Dragon departs from the station, it will conduct a deep orbit burn, which will last about 9 minutes and 10 seconds. It'll then take about 30 minutes for Dragon to re-enter the Earth's atmosphere for its parachute-assisted splashdown in the Gulf of Mexico, outside of Tallahassee, Florida, around 10:30 p.m. Central Time, 11:30 p.m. Eastern. There are a couple milestones we'll see Dragon meet this morning. First, those departure burns, but then it will cross the keep out sphere, an invisible line around the station with a 200-meter radius. It will keep heading away from the station and will stand by until it makes its way out of the approach ellipsoid, another invisible line considered the neighborhood of the space station. These invisible lines are where we have checkpoints for the vehicle on the way to and from the International Space Station. Once the command to undock is sent, we'll be looking for 2 sets of 6 hooks from the International Space Station to be released from Cargo Dragon. After open, 2 small undocking burns that will last less than a few seconds, and we'll begin to see separation of the vehicle. The spacecraft will then start to slowly drift away. Next, Dragon has a few departure burns to get it into the proper position away from the International Space Station for its eventual deorbit burn, scheduled for tomorrow at 9:45 p.m. Central Time. That will slow Dragon down enough to drop it out of orbit and send it towards its landing zone, splashing down at approximately 10:30 p.m. Central Time on the coast of Florida. Splashdown will not be covered live, but to keep up with the mission, go to www.nasa.gov.
Right on 2.
Hey, Aki, just wanted to verify that you guys got all the USOS shutters closed. We're about to do our go, no-go down here.
Yes, sir. Sorry, I didn't mark it complete, but yes, those are complete.
And we copy. Appreciate it.
You're currently getting a live view of the Dragon cargo craft still attached to the International Space Station, as it will be for the next 15 minutes or so, before it undocks for its return to Earth, carrying over 5,000 pounds of research and return cargo. Among that research and return cargo are samples, hardware, and data for completed investigations. The molecular muscle experiment 2 is one of the investigations returning on Dragon today, which was an experiment to measure muscle.
Dragon is go for undocking and departure. Perform step 2 through end in 1.602 Dragon departure monitoring.
And that was Leslie Ringo, Capcom, communicating to Shane Kimbrough in the cupola today, monitoring that Dragon has a go for undocking.
Station Houston and 2 for Dragon. Dragon is go for undocking and departure. Perform step 2 through end in 1.602 Dragon departure monitoring.
Copy step 2, and ISS crew is ready for Dragon undocking.
Copy.
We are currently in a brief handover between satellites, but we'll have communication back shortly. While we wait, let's talk about some of the research and return cargo that Dragon will be returning tomorrow once it's splashed down. The molecular muscle experiment 2 is one of the investigations returning on Dragon tomorrow, which was an experiment to measure muscle strength in worms to test whether decreased expression of muscle proteins is an association with decreased strength, which could support development of countermeasures to help maintain crew member health. Another investigation returning to Earth on Dragon tomorrow is the lyophilization 2, which examines how gravity affects freeze-dried materials. Formulating pharmaceuticals using lyophilization or freeze-drying improves their stability and shelf life and could enable long-term storage of medications and other resources on future long-duration space missions. Also returning on Dragon is the oral biofilms in space studies, evaluating how gravity affects the structure, composition, and activity of oral bacteria in the presence of common oral care agents. Findings could support development of treatments to fight oral diseases. Again, these are only a few of the science investigations returning to Earth on Dragon tomorrow for further analysis and results. The International Space Station continues to serve as an essential test bed for people on Earth and in orbit as we continue to move forward, placing the first woman and person of color on the moon and eventually on Mars. You're currently looking at a live view of the International Space Station Flight Control Room. About 5 minutes ago, Flight Director Paul Kanya took a final go-no-go poll from flight controllers around the room here in Mission Control Houston to make sure all systems were a go before the release of Dragon this morning. The go for undock was confirmed by Leslie Ringo, relayed to Shane Kimbrough, who's monitoring Dragon's departure today in the cupola module. We are looking for the release command or undock command from Dragon to be sent around 9:40 a.m. Central Time. We're waiting for that, and that's about 3 minutes out. The command has now been issued for undocking. We are now looking for 2 sets of 6 hooks to open. Hooks are currently driving. The first set of hooks are open, and we're looking for the second to be underway. Station Houston and 2, the first set of hooks are open. Dragon is committed to undock.
Copy. Thanks.
And the second set of hooks are now opening. All hooks have now been opened.
Station Houston on 2, all hooks open.
Copy.
Release has been confirmed at 9:45 a.m. Central Time.
Physical separation visually confirmed.
Copy.
That was Shane Kimbrough relaying that release has been confirmed at 9:45 a.m. Central Time as the International Space Station Dragon were flying 262 statute miles above the South Atlantic Ocean. And that first undocking burn has been completed.
Dragon departure burn 0 is complete.
Copy, departure burn 0 complete.
Dragon is now in retreat mode, and after a series of departure burns, we'll continue to pick up a little more speed to move Dragon out of the keep out sphere and then the approach ellipsoid this morning.
Houston Station and step 4, we're showing source slot 4, ISS thrusters enabled.
We copy.
We're about 2 minutes out from that next burn. This burn will take Dragon out of the keep out sphere, that first invisible line with a 200 meter radius, to get the cargo Dragon away from the International Space Station.
Station Tsukuba on Space Ground 2 for Aki at your convenience. Copy.
And we're about 30 seconds out from the next burn.
Station Houston on 2, departure burn 1 complete.
After that, looks like it's right down the chute in the corridor.
Copy.
Leslie Ringo confirmed with Shane Kimbrough that the last burn was completed and it was nominal.
Station Houston on 2, Dragon has exited the keep-out sphere.
That's great news, Leslie. Hey, I want to say thanks to all the SpaceX team, the NASA team, and all the scientists, engineers, and researchers who had equipment and on this vehicle. It was a great vehicle, kept us busy for this past month, doing a bunch of great science. Hopefully the returns that you get back on this vehicle here in a few days will prove to be good insight for all the researchers there. And obviously it brought out the solar arrays as well that we got to install on our EVAs, so it kept us nice and busy. So thanks to everybody again, and it looks like a beautiful vehicle departing.
And that was Capcom Leslie Ringo confirming that Dragon is outside of the keep-out sphere and a bid farewell to Dragon by NASA astronaut Shane Kimbrough. And that same burn that helped Dragon exit the keep-out sphere will also help Dragon exit the neighborhood or the vicinity of the International Space Station. And we're looking for Dragon to exit the approach ellipsoid in a little under 10 minutes. If you are just joining us, we are live here in the International Space Station Flight Control Room with a live view of the SpaceX Dragon cargo craft as it has undocked the International Space Station and now is retreating. It has currently exited the keep out sphere, and we're looking for one more milestone this morning, and that's going to be the exiting the approach ellipsoid. Cargo Dragon arrived on June 5th, 2021 with over 7,300 pounds of cargo. Cargo Dragon will return tomorrow, splashing down in the Gulf of Mexico off the coast of Tallahassee, Florida, with about 5,300 pounds of research and return cargo. Dragon had an on-time departure of 9:45 a.m. Central Time as the International Space Station and Dragon flew 262 statute miles above the South Atlantic Ocean. Now just about 4 minutes away from Dragon departing the approach ellipsoid, which is the mythical cone around the station, referred to as the neighborhood of the space station, at which point integrated operations between Flight Control Team here in Houston and SpaceX Flight Control Team in Hawthorne, California, will be complete. At that point, NASA's tasks as part of the joint mission operations will be complete as flight controllers in the SpaceX Mission Control Center in Hawthorne, California, take over operations of the Dragon cargo craft. Just to recap some of the milestones from our coverage so far today, the command for undock was sent at 9:40 a.m. Dragon had 2 sets of 6 hooks released and had a successful undocking at 9:45 a.m. Central Time, 10:45 a.m. Eastern. It then conducted a series of departure burns to move away from the space station. Flight controllers here in Mission Control Houston and SpaceX Mission Control worked with Expedition 65 flight engineer Shane Kimbrough monitoring in the cupola. Dragon has now exited the keep out sphere, and we're just a few minutes away from Dragon exiting the approach ellipsoid, or the vicinity of the International Space Station. It will then keep moving away from the station, and it will have an eventual deorbit burn tomorrow around 9:45 p.m. Central Time for a parachute-assisted splashdown at 10:30 p.m. Central Time, 11:30 p.m. Eastern Time.
Houston Station on 2 for Dragon monitoring tools teardown.
Go ahead, Mark.
Leslie, I'm in step 1, step 1.1. I was expecting to find a window called desktop streamer on SSC 17, but I don't see it. Does that mean I can skip this step?
Affirmative, you can skip this step.
Thanks. And also, I'm not seeing Dragon 2 docking monitor.
Checking. And Mark, the docking monitor is really for approach only.
Happy, thanks. The station on 2 for Dragon monitoring tools.
Go ahead, Mark.
Step 4, I'm not seeing DAS on SSC 17, so I suspect that's the goal.
Checking.
A little more clear. Step 4.1, right-click DAS icon on system tray. I don't see that icon in the system tray.
Okay, copy. You do not see the icon.
And I take that back. I just found it. I just got to look more carefully.
Okay, copy. You found it.
Dragon has now exited the approach ellipsoid, and Dragon will now be commanded by flight controllers in the SpaceX Mission Control Center in Hawthorne, California. Another day of travel, Dragon will continue to have a series of departure burns to an eventual execution.
Dragon is outside of the approach ellipsoid on a 24-hour safe free drift trajectory.
Copy, thanks.
And that was Capcom Leslie Ringo confirming that Dragon is outside of the approach ellipsoid. Dragon will now be commanded by flight controllers in SpaceX Mission Control Center in Hawthorne, California. Dragon will continue to have a series of departure burns to an eventual execution of a 9-minute, 10-second deorbit burn around 9:45 p.m. Central Time tomorrow. That will slow Dragon down by just over 64 meters per second, allowing it to drop out of orbit for its descent back to the Earth's atmosphere, and a parachute-assisted splashdown in the Gulf of Mexico off the coast of Tallahassee, Florida, around 10:30 p.m. Central Time, 11:30 p.m. Eastern Time. Splashdown will not be broadcast live, but to continue to follow the mission, go to www.nasa.gov. Recapping the events from today, Dragon was set free at 9:45 a.m. Central Time as the International Space Station and Dragon were flying 262 statute miles above the South Atlantic Ocean. Dragon then executed a series of departure burns to move to a safe distance away from the station, where it will continue to move for the next day before it has a deorbit burn at 9:45 p.m. Central Time tomorrow. Dragon's parachute-assisted splashdown is scheduled to happen around 10:30 p.m. Central Time, 11:30 p.m. Eastern Time, off the coast of Tallahassee, Florida. The NASA and SpaceX recovery teams will be on the scene and splashdown zone ready to retrieve Dragon and its nearly 5,300 pounds of cargo and return science. Dragon will then make its trip back to port for the unstowing of that research and return cargo. With Dragon now safely on its way back to Earth, that'll wrap up our release coverage for today. This is Mission Control Houston.
The magic of the space shuttle is just its enormity. It's huge. And it flies up and back, and there will be no parallel like that, I think, for 100 years.
I think the shuttle has been one of the most marvelous vehicles that has ever gone into space or done anything.
So you can imagine the early spacecraft, barely the size of a desk for 1 or 2 astronauts. Now the spacecraft is the size of an airliner.
When you saw it, you thought, how can something like this fly? You've got all these tile on the bottom of it, and it's like bricks if you want to look at it that way.
There was never a spacecraft like it, as large as a DC-9 airliner, but strong enough to withstand the vacuum of space, big enough to carry huge satellites, and built to be reused dozens of times. And it had wings, just like the imagined spaceships science fiction writers designed for their fantastic tales of adventure.
And the sophistication of that, again, compared to the earlier vehicles, was difficult to get accustomed to, particularly since we were making the transition from the era of wires and switches and meters to digital and computers.
When STS-1 came in, it was a totally new vehicle. A lot of work left to be done on it. We still had to do hydraulic lines in the aft, APU lines in the aft. Had well over thousands of tile to go do yet to put on the spacecraft. The time frame as far as getting the overall integrated schedule, it was really hard and difficult on a lot of people. Pretty much 3 shifts a day, round the clock, 7 days a week, 365 days a year.
NASA built 5 shuttles to go into space, naming them after ships of exploration in previous generations. Columbia, Challenger, Discovery, Atlantis, and Endeavour. They were larger than any other spacecraft, capable of carrying 25 tons in its 60-foot-long cargo bay. Another difference with previous spacecraft, shuttles could bring large payloads back, giving scientists a chance to see their experiments' results firsthand. The shuttles also carried more people on a single flight than ever before. The shuttle flew crews of 8. The previous record was 3. Shuttle astronauts also looked different than the flyers of previous programs. Women and minorities would be seen working in space throughout the shuttle program. Astronauts ranging in age to John Glenn's 77 made their way into space on shuttles. Scientists have used the space shuttle as a platform to study our own planet, life and material science, our solar system, and the universe itself. Perhaps its most famous accomplishment is NASA's Hubble Space Telescope, which has dazzled us for more than 20 years with discoveries wrapped up in unimaginable beauty. 5 teams of astronauts worked on the observatory as it orbited Earth, giving life and capabilities far beyond what it launched with.
Servicing the Hubble Space Telescope, I think, is one of the Space Shuttle's finest accomplishments. We've had several servicing missions. They saved the Hubble Space Telescope on the very first mission, if you will, and it's just that we've extended the life of the Hubble Space Telescope for so many years, and the things we've learned from the Hubble and other telescopes up there are just astounding nowadays.
T-minus 10 seconds, go for main engine start. 7, 6, 5, 3 engines up and burning. 3, 2.
This is Shuttle Launch Control, T-minus 3 hours and holding. Here's our commander, Chris Ferguson. He's in the suit-up room. He's having a fit check of his helmet. He's our commander on this flight, and going over to pilot Doug Hurley. This is his second trip into space. He completed his first space flight on STS-127, and he's logged more than 376 hours in space. And here is Mission Specialist number 1, Sandy Magnus. This is her third space flight. She spent more than 4 months in space aboard the International Space Station. She flew on STS-112, logged 11 days in space, and then 4.5 months after being on board the space station as a member of the Expedition 18 crew. This is Rex Walheim. He's our mission specialist number 2. He's making his third space flight. He's spent more than 24 days in space on STS-110 and STS-122, and he's had 5 spacewalks totaling more than 36 hours. And he's served very effectively as the chief of the EVA branch. So the crew now is finishing their suit-up activities, and they are scheduled to leave for the launch pad in just about 25 minutes. And here they come. Crew going down the elevator, where they'll be greeted by employees from Kennedy Space Center and members of the news media. This is the same elevator It's been used by the astronauts ever since Apollo. And there they go, escorted by NASA security. There'll also be a helicopter flying overhead. It's about a 20-minute ride out to Launch Pad 39A. This is Shuttle Launch Control, T-minus 2 hours, 31 minutes, 5 seconds, and counting. The flight crew is now in the white room of the orbiter access arm. Members of the closeout crew are in the white coveralls, and the astronauts, of course, are in the orange pressure suits. The closeout crew will be assisting the astronauts with their helmets and other equipment as they enter the orbiter.
This is an incredibly experienced and dedicated team that gets the people on the orbiter, and Travis is in charge of the whole thing. And not only is he in charge of this one, but he's in charge of the whole closeout crew. We can see here Chris Ferguson getting put into his seat. And the folks that are helping him get in his seat there are the number 2. If you can see the number 2 on him is Randy Brezhnik. He's actually a Marine Corps colonel. He's one of our astronauts. You can see him in the one screen. And Randy is actually getting on there to help out with the communications sections and all those kind of things. But the guy running the operation is Drew Billingsley, who's number 3. And you can see him kind of climbing all over there. If you look in the view there, you can see Chris Ferguson right in front of us and kind of behind to the right, kind of leaning over is Randy Brezhnik, number 2, and now disappeared from sight is Drew Billingsley. He's called the flight deck crew insertion technician, the one that gets him on the upstairs. Born in Santa Monica, California, and grew up in Huntington Beach. Served in the U.S. Army. He's been in this role for a long time. He was initial suit tech in STS-86 back in 1997. What they're doing as they go through here is, as Chris gets in the seat, there's probably about 9 different connections that need to be made, both to the vehicle itself as well as within his own gear there. And as you can see, we're pretty much, as astronauts, just hanging back and letting them do it. The best thing we can do is let these professionals do their job. So you can see Chris is just concentrating on getting his hands out of the way and making sure that Drew has access to what he's working over on the right there is his liquid cooling. You've got all the straps that have to come around. It's a 5-strap harness. You have to get the parachute, which is what you're seeing there. Randy has the close one, and Drew has the far one. You got the parachute straps that are waiting for you. The parachute's already in the seat when you get in. They put those over the side, and they connect those in. You'll see a real good shot of that right here. You'll see them connected into the straps that Chris is already into, that he came in with his his chest strap and everything, so that gets connected there. And they're essentially doing all these connections to make sure he's nice and snug in there and all ready to go. So you talk about the two guys in there. Drew is this is be his 11th mission. I'm trying to remember Randy. And this is Randy's first one as the number 2. So this is the first time he's actually inside the vehicle doing this setup here. So I'm sure he's having a lot of fun.
And this looks like Doug Hurley.
Yes, it'd be Doug Hurley going in, Marine Colonel. He is flying as a pilot on this flight. This is his second flight. Flew a few years ago on 127. And he's being helped there. You can see the guys out in the white room to get everybody ready to go. Number 4 there is Renee Arians. He's another longtime member. And by the way, all the guys that we've talked about so far are USA employees, other than Randy Brezhnik, of course, who's the astronaut. But Renee has been with the United Space Alliance for a long time. 27 years in the space program. He's been for 40 launches. And he's just doing a great job for us. He's been the OVCC. He's actually had Travis Thompson's job. Travis is number 1. There's only about 3 or 4 people that are qualified to do that job at any one time, and Renee is another one, but in this flight he's actually filling the number 4 role. And so he does a great job with it. He's going to be the hatch technician when they close the hatch and take care of all that stuff.
I mentioned Randy Brezhnik. He's the ASP, right? Astronaut Support Person.
Yep, it's called Astronaut Support Person, yeah.
When does he get on board? He gets on fairly early, doesn't he?
He does. He comes out and gets everything prepared inside the crew cockpit before the crew gets out there and makes sure that all their gear is in place. There's a lot of things they don't bring with them. They don't carry out with them that we take out for them. And I did this job quite a while ago, and there's a lot of things you take out there, get ready. You essentially triple check the cockpit to make sure everything's in place. You can see Drew there working with Chris Fergie's communication gear. That's the white line that's coming down. It's actually from the back of the helmet that connects into the system, but that's the line that communication comes through. So you see that wraps around a couple times. And the black piece of gear we call the hot dog there, that's the quick disconnect. Everything that he's being strapped into the shuttle with has a quick disconnect so they can just pull things instead of having to tightly undo things. Everything just has a quick pull that they can take apart in case they would have to get out. If there's some kind of emergency at the pad and instead of launching, they're going to have to get out. There's a bunch of quick disconnects you pull so they can just, for Chris, he would roll to his right, drop down on the MS2 seat, which not Drew, but Randy Brezhnik is kind of on over there on the left. He would drop down on the seat down there and then get out of the vehicle. So that's part of the reason why it takes so long, is because everything's an intricate thing. You don't want anything to be tangled up. You don't want anything that can slow the crew member down if they need to get out of the vehicle. So.
And this is Sandy Magnus. She's our mission specialist number 1. So when she gets in, I think she's going to be on the flight deck in the aft right seat.
Step 628.
That's correct. We got a good view of it now.
They are complete.
Doug has gotten in from the middeck, and you kind of have to go in through the middeck through the hatch, and in the middeck you kind of take a right, about a 90-degree right. You have to go through the ladder access, which normally when you're vertical you'd be climbing the ladder. In this case you're going right, and then you actually crawl on the aft panels, and you can see that Randy's actually standing on the aft panels there as he gets folks ready to get in the vehicle. So we've got things down there that protect the aft panels, a certain place where you can stand. Like you notice, for instance, Randy's not standing on the switches. We can't stand there. But it's kind of intricate. You have to weave your way around, and so you come in the hatch, you turn to your right for about 90 degrees, go about 5 feet, you drop down to the aft panels, aft lower panels of the flight deck, and then you climb up on the Mission Specialist 2 seat, and then you have to get yourself up in the pilot or commander seat. So these are the hardest 2 seats to get into, and it's kind of a monkey bar thing. There's a grip up there that they grab with their hands, and then they put their feet up there, and oftentimes you'll see the technicians, either Drew or Randy, helping them get their feet up there and get all situated. And then the critical thing is getting yourself on the parachute correctly. You want to get yourself all the way down in the seat as far as to the seat pan as you can, because the shoulder straps of the parachute can be quite painful if you don't get those a little bit loose. So you want to make sure you're as far down in the seat pan as possible. So you'll see a lot of adjustments here where they're pushing on them and pulling on people and getting them in the right place. And it's kind of a manhandling task. Obviously with the suit weighs a lot. It usually weighs about 50 to 60 pounds, and so they're carrying a lot of extra weight, and it's bulky, and it's hard to get where you want to go. And that's why we have so much extra help in there for these guys. This job is almost impossible to do yourself on the ground. On orbit, it's pretty easy. You just have to set things up and you're floating, so it's a lot easier. You can move around a lot more readily, and the bulkiness doesn't hurt you nearly as much when you're in 0G.
CMT and MT adjustment is complete. Ready for IMU platform positioning. Copy that.
Next milestone is a check of the orbiter's flight controls.
GLS is go for purge sequence 4.
And there will be a steering check of Atlantis' 3 main engines. Verifying now that the main engines are in their start position.
GLS is go for ET LO2 pressurization.
Starting now the retraction of the gaseous oxygen vent arm, the vent hood.
TLT OTC, clear caution warning memory, verify no unexpected errors.
Fuel cells going to internal. External tank camera being activated at this time.
OTC, PLT, no unexpected errors.
Copy that. Flight crew OTC, close and lock your visors and initiate O2 flow.
That's in work.
T-minus 2 minutes.
GLS is go for ET LH2 pressurization.
Solid rocket booster camera is being activated. T-minus
30 seconds.
sound suppression water system is being armed. T-minus 1 minute. But oxygen and liquid hydrogen fill and drain valves are closed. T-minus 40 seconds, handing off to Atlantis' computers at T-minus 31. T-minus 35, 33.
Clock will hold at T-minus 31 seconds due to a failure.
And we have had a failure. Grad-Lot sequencer.
We had a problem on the GOX retract switches. NNTDSP. Go ahead. Yes, sir. We need guys to go do the verification per the LCC, please. All right, CMAC.
Yes, CMAC. The LCC says we need to verify using a camera, and we're positioning camera 62 right now.
Okay, let us know as soon as 62 is swung over and you can verify LCC for GVA retract, please. And all personnel, we're holding here at 31 seconds while we get a verification that the GVA has fully retracted per our pre-plan.
This is CMAC. We verify retracted.
Okay, and you can verify that it is fully retracted per the instructions that that we developed, correct?
That's correct.
All right, and SPE? And NTD, SPE concurs. They satisfy the requirements of GSE 13 pre-plan contingency. I am go. Okay, I copy. And launch director?
Yes, sir. I heard all that and concur. Press on.
All right, very good. NTD, SPE? Yes, sir. Yes, sir. I need concurrence to GLS and mass to clear the hold, please. Very good. And GLS, you have concurrence? Go. Copy that. It's in work. Thank you. Let us know when that's complete. NTD, we have it in work.
All right, guidance.
And just a reminder for folks, our lock spin back hold time is 3 minutes and 16 seconds. NTD, CTLS on 212, we're ready to go. All right, very good. And launch director, with that cleanup, we're going to go ahead and proceed. Yes, sir, please do. All right, and all personnel, we are going to pick up the clock here momentarily. And GLS, you can resume the clock on your mark.
Copy that. Countdown clock will resume on my mark. 3, 2, 1, mark.
E-minus.
Go for auto sequence start.
Handoff to Atlantis' computers has occurred. Solid rocket booster nozzle steering check and work.
20.
Firing chain is armed.
15.
Go for main engine start. T-minus 10, 9, 8, 7, 6, 5. All 3 engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
Program, Houston.
Roger, roll, Atlantis. Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. 24 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 40 seconds into the flight, the 3 liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time. Engines now revving up, standing by for the throttle up call.
Atlantis, go at throttle up, no action, DPDT.
Go with throttle up, no action on DPDT.
That call from Capcom Barry Wilmore, a transducer, instrumentation only, no action required. Atlantis now 15 miles in altitude, already 16 miles downrange from the Kennedy Space Center, 1 minute 40 seconds into the flight. Atlantis flexing its muscles one final time. Atlantis traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange, standing by for solid rocket booster separation. Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. The main engine steering the shuttle on a pinpoint path to its preliminary orbit. 2 minutes, 20 seconds into the flight. Atlantis already traveling 3,200 miles an hour, 35 miles in altitude, 50 miles downrange. The propulsion officer reports the orbital maneuvering system engines have ignited. Atlantis kicking on its afterburners for 1 minute, 23 seconds for the final phase of powered flight.
Atlantis, 2-engine TOW.
2-engine TOW.
That call from Capcom.
Single pane day, so in the event of contingency, you're in plane plus 230 on the eCal page. No comm VIs when you're ready to copy.
Okay, in plane plus 230, go ahead.
Press to ATO, 10.8. Press to MECO, 14.7.
Press to ATO, 10.8. Press to MECO, 14.7.
That's a good read back, Atlantis.
Because of the slightly late launch time, Capcom Barry Wilmore reading up to pilot Doug Hurley the updated abort boundaries for Atlantis, which is flying on the singular power of its 3 liquid fuel main engines, draining 0.5 ton of fuel per second from the shuttle's large fuel tank. 3.5 minutes into the flight, Atlantis traveling 4,200 miles an hour, 54 miles in altitude, already 120 miles downrange from the Kennedy Space Center. 3 good main engines, 3 good auxiliary power units, 3 good fuel cells for Atlantis.
Atlantis, negative return.
Negative return.
That call from Capcom Barry Wilmore indicating that we're too high in altitude, too far downrange to return to the launch site in the event of an engine failure. However, Atlantis' 3 engines performing perfectly. 4 minutes, 20 seconds into the flight. Atlantis currently traveling 5,500 miles an hour, 62 miles in altitude, almost 200 miles downrange. 4 minutes of powered flight remaining. Atlantis speeding straight as an arrow toward its date with the International Space Station Sunday morning. Coming up on the 5-minute mark. Atlantis now traveling 6,500 miles an hour, 66 miles in altitude, 250 miles downrange.
Atlantis, press to ATO.
Press to ATO.
That call indicating we can make minimal orbital targets in the event of an engine failure. All 3 engines continue to function normally. Atlantis will begin its slow roll to a heads-up position shortly. Five and a half minutes into the flight. Atlantis traveling 7,700 miles an hour, 315 miles downrange.
Atlantis, single engine, ops 3.
Single engine, ops 3.
And the guidance officer here in Mission Control confirms that the computers are commanding the main engines to swivel.
Engine Zaragoza 104.
Single engine Zaragoza 104.
We've rolled to a heads-up position now, providing better communications to the tracking and data relay satellite system as Atlantis heads uphill. 6 minutes, 20 seconds into the flight.
Atlantis, press to MECO.
Press to MECO.
That call indicates that we can make our normal orbital cutoff targets in the event of an engine failure. However, all 3 main engines continue to function normally.
Nominal. Fergie, go the plus X, go the pitch.
Nominal set down plan. Go for the plus X, go for the pitch.
That call indicating that we will be in good shape for the orientation of Atlantis for external tank photography following main engine cutoff. Now 7 minutes into the flight. One minute, 20 seconds till main engine cutoff. Atlantis traveling 12,000 miles an hour. The main engines will soon be throttling down once again to limit the stress on the shuttle and its 4 crew members to that of 3 times the effective gravity. Atlantis currently traveling at a speed of more than 4 miles a second. 1 minute of powered flight remaining for Atlantis. Three good main engines, 3 good auxiliary power units, 3 good fuel cells. Approaching the 8-minute mark into the flight. Atlantis now traveling more than 15,000 miles an hour. Eight minutes, 15 seconds into the flight, standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank. Booster officer confirms main engine cutoff. For the last time, the space shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation. Atlantis off the tank. Commander Chris Ferguson will be maneuvering Atlantis now into an orientation to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away.
So OMS 1 is not required. Your preliminary OMS 2 TIG, 37 minutes.
37 minutes, no OMS 1 required, thanks.
This is Mission Control Houston. Atlantis safely in its preliminary orbit. Following a flawless launch from the Kennedy Space Center, albeit about 2.5 minutes late at 10:29 a.m. Central Time. The launch slightly delayed while engineers at the Kennedy Space Center confirmed the complete retraction of the gaseous vent arm at the launch pad. Commander Chris Ferguson is currently orienting Atlantis into the proper attitude to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away for the final time. Atlantis currently in an orbit of 140 by 36 statute miles. That's the preliminary orbit that will be increased in altitude at its apogee through the firing of the orbital maneuvering system engines 26 minutes from now.
Houston, Atlantis, you ready for MTS TVC ISO?
That's affirmative, Chunky. We are ready. Chunky, also, after you get those closed, we'll be ready for APU hide shutdown. On 3-4, the only delta is tele-only control is not required. And when you get ready for Ops 105, we are ready as well.
We copy all. APU hide shutdown on 3-4, except tail-only control not required, and we're ready for 105.
That's a good readback.
This is Mission Control Houston here in the shuttle flight control room. Post-insertion activities underway under the direction of Ascent Flight Director Richard Jones, second from your right, who presided over all of the work that was done associated with making sure that the weather was acceptable for launch from a return to launch site abort standpoint for the Spaceflight Meteorology Group. On the far right, Flight Director Tony Sacacci, he will preside over Atlantis' final entry 12 days from now. Butch Wilmore, Barry Wilmore, the Capcom, the spacecraft communicator, in the dark shirt, and on the far left, Lee Archambault, the astronaut who was in direct contact with Deputy Chief Astronaut Rick Sturckow. Sturckow was assessing the weather and real-time observations as he flew the shuttle training aircraft around the vicinity of the Kennedy Space Center in the final hours prior to launch. Handshakes all around here in the shuttle flight control room. As we move into the post-insertion time frame, the initial phase of getting Atlantis set up for orbital operations, the countdown clocks here in Mission Control currently ticking backward to the first firing of the orbital maneuvering system engines in what is known as the OMS 2 burn, just a bit under 22 minutes from now. That will begin to raise the orbit, the apogee of Atlantis' orbit. Essentially, the launch itself was the first rendezvous maneuver to catch up to the International Space Station for a docking on Sunday morning. With Atlantis in the early minutes of its final flight, and the final flight in the history of the shuttle program, we're going to go back down now to the Kennedy Space Center at the launch site for replays of today's launch that occurred at 10:29 a.m. Central Time.
TIG of 37:45, we like that, and no deltas, the 3-6 or 3-7.
Houston, just to tag up with you, we show ourselves complete through the MPS power down, just waiting on your go when the time comes.
Okay, we are ready for MPS power down when on time, and if you could check the MPS pneumatic helium ISO to GPC, that should get them.
Okay, pneumatic helium ISO to GPC. Thanks for the check.
As we watch the replays of Atlantis' final launch, Capcom Barry Wilmore talking to Commander Chris Ferguson on board Atlantis. The main propulsion system has been shut down. The external tank umbilical doors have closed. The auxiliary power units have been shut down. Everything going well. Less than 22 minutes following Atlantis' launch. The crew on board Atlantis will be busy over the course of the next several hours setting up shop on board the orbiter, activating payload buses, breaking out laptop computers, preparing for the opening of the payload bay doors, after which the Ascend team of flight controllers will assess all of Atlantis' systems for a go for on-orbit operations. A slightly longer workday than usual for the crew of Atlantis, since there are only 4 crew members on board instead of the usual 6 or 7. Later in the day, the checkout of the shuttle's robotic arm, along with other activities preparatory to the inspection that will take place of Atlantis' thermal protection system tomorrow, standard customary operations for the second day of any shuttle flight.
Houston, Atlantis, MPS power down is complete, and with that, we would like to thank the Pratt & Whitney Rocketdyne team and the SSME team for their flawless performance over this 30-year shuttle flight history. 135 flights. It's a 7,000-pound engine that puts out 1.5 million pounds of thrust, and they pitch the equivalent of a perfect game every flight. From everyone who's ridden on these rockets, we thank you.
We concur with that assessment, Atlantis. Good and pertinent and true words.
We're putting ET umbilical door closure in work, Butch.
Mechanical Systems Officer here in Mission Control, watching over the closing of the external tank umbilical doors. Words of compliment from pilot Doug Hurley for all of the propulsion system engineers who presided over 135 flights of the Space Shuttle, and the performance of Space Shuttle main engines, the external fuel tank, the solid rocket boosters that propelled these vehicles, and hundreds of humans to orbit.